Hello everyone, so in this video we are going to talk about the photochemistry of aromatic compounds. Now we have talked a lot about this photochemistry. If we go through our playlist, I'm going to put the link here. You will see we have talked about the introduction and irradiations, T1 state, S1 state. Likewise, we have talked a lot about the photochemistry. So you can go through a photochemistry playlist and see is there any specific videos that you would like to see before you continue the sessions, right? Now in this particular video we are going to talk about the irradiation of benzene, and specifically we are going to see ring isomerization based on photochemistry. Now before we going straight into this isomerization, right, I want you to introduce some specific structure. Okay, now to introduce this structure I am going to take this benzene. Here we have the benzene. Now what you want to do is we are going to irradiate this. Now this irradiation you have to select two bonds, right? Any two bonds. Let's take this bond and this bond, right? What you want to do is you're going to break this bond here. One electron is going here to form a radical. The other electrons I'm going to take it here to form a new bond between this carbon and between this carbon. So here this bond I have broken into two electrons. Now one electron is going here to form a radical. The other electron is going into here to form a bond with this guy. Okay, this bond here I'm going to break it too, and I'm going to take one electron and come here to form a new bond between here and here. The other one I'm going to just stay here to form the radical. Now we have the structure like this. Okay, let me draw it. This bond is the same, there's nothing changed in this particular position, but this position is changed, right? Now there's no bond here, there's a radical and a new bond between here. Look at this, this carbon and this carbon. Okay, so there's a new bond between this carbon and this carbon, and there's another radical here. We call this particular radical as 1,3 biradical. You can see that there are two radicals, and these radicals are on 1,3 position. Now the next step is, okay, look at this, the formation of new bond from these two radicals. So these two radicals are going to come together here to form a new bond between this carbon and this carbon. I'm going to draw the final structure. Now we call this structure as benzene, right? I'm very sorry if I'm pronouncing it wrong. Let me write it for you, right? Sorry, let me go correct it. There's no L. This one, benzene. Okay, benzene. Now this particular compound, benzene, right? This is thermally unstable. This is thermally unstable. So what happens is when this particular product is formed, this will go back into the benzene very quickly because it's unstable. But we need this structure when it comes to this isomerization. So let's take an example and see how these isomerizations work. Okay, so we are going to take an example. Okay, here this structure here, benzene structure. Here we have a substitute as Z, and also we have one thing as X. So I'm going to draw the three bonds like this. So what we are going to do is we are going to isomerize this compound. Otherwise, we are going to change this compound's positions like this. So we are going to see how this reaction, otherwise how this mechanism work in stepwise. Now the first step would be the formation of benzene. Here this one. So what happens is you have to choose two specific bonds, right? You have to choose two specific bonds. I'm going to choose these two bonds. Now what happens is this bond is going to be broken, so one radical is forming here and the other electron is going here to form a new bond between this place and this place. Same thing happens here. This electron comes here to form the new bond and the other one is coming here to form the radical. Now here we have the structure. This bond is the same. Now here we have a radical here, we have a radical here. Just the same thing, right? Just the same thing as we have done before. There's a new bond between here and here. And the next step would be the formation of the other bond between this radical and this radical. We have the new structure. Now there's a new bond here and also a new bond here. Okay, now we are halfway done with our mechanism, right? The next step, you need to be very careful now, right? So look at this, look at what I'm going to do. Now I have to form another bonds, right? I need two pi bonds in order to form this structure. As you can see, this is a benzene structure, right? I have only one pi bond here, so I need another two pi bonds. So what I'm going to do is I'm going to break this bond. Okay, I'm going to break this bond and this bond. Here, look at this. I'm going to break this bond and form a radical in this place, and the other electron I'm going to take it here to form a double bond between this position and this position. So I'm going to do the same thing here, this bond also. Take one electron and coming here to form a double bond, and the other one will stay here to form the radical. Now I have the structure like this. Let me erase these parts. Okay. Okay, now we have a double bond between here. Right? We have a double bond here and we have two radicals. Now these two radicals are going to come together. Okay, these two radicals are coming together to form a new double bond between this position and this position. If you look very closely, it's the same thing which we have done in previously, right? Same mechanism. So let me draw the new structure. Here we have the X. Now we have the bond here, and we have a new pi bond. Here the same thing here. Okay. Here we have the structure. Now look carefully, right? Now what I'm going to do is I'm going to stretch this structure out. To do that, I'm going to number the carbons. So let's take another color. Let's say blue. Okay, I'm going to start with this Z and going right hand side, right? Here 1, 2, 3, 4, 5, 6, and there's no 7. I'm going to do the same thing here, right? I'm going to do the same thing here. 1, 2, 3, 4. Here, look at this. I'm going to start from here. 1, 2, 3, and then it's going for here. Not here. I'm connecting to this carbon, so it's going to be 4. And then 5. So this carbon is connected to this one, which is 6. If you stretch this out, right? If you stretch this out, look at this. This is the structure you have. 1, 2, 3, 4, 5, 6. You can see the X is on the 5th position, right? In this case you have the X on the 4th position, but in this case you have it on the 5th position. So we have changed the position of this particular X. This is the mechanism, right? Normally, like, you have to write it down for several times to understand it completely. So I highly recommend you to write it down on your own to get a complete idea about it. So I'm going to do another example. So if you are okay with it, so then you can close the video. Don't need to waste your time. I'm going to do another example if you have missed something out. So in this particular example, I'm going to take this structure. So here we have 3 pi bonds. Now we call this structure as O difluorobenzene. O difluorobenzene. There are two fluorine atoms. I'm going to change this into the structure of this one. Okay, let's see how we can do this, right? Let's see how we can do this. First thing is, you have to select two bonds, right? Basically I'm going to choose these two bonds. Now, just like we have done, we have to form the benzene, right? So let me break this into here to form the radical, and the other electron goes here to form a new bond. So here this one goes here to form the new bond, and this one here to form a radical. So I have biradical on the 1,3 position, here a radical and a new bond between here to here. This bond doesn't change. Here we have a new radical and a fluorine. Here also we have a fluorine. And then the next step, join two radicals back again to form a new bond between this carbon and this carbon. So here we have the structure. Now we are halfway through, right? We are halfway through. Now what we need to do is, we are going to break two bonds and form new bonds. Form two new bonds. I'm going to choose this bond and this bond. If you see carefully, it's the same thing that we have done, right? It's the same thing. So I'm going to break this bond to here to form a radical, and the other electron I'm going to put here to form a double bond between this carbon and this carbon. Same thing I'm going to do to this place. Break one electron and come here to form the pi bond, and the other one will go here to form a radical. Now I have the structure like this. I have a radical here, and I have double bond between this place and this place. So no, let me draw it again for more clear structure. So okay, now I'm going to erase these two bonds, right? Now we have a bond here and we have a bond here. Okay, and as you can see here, we have formed a double bond between this position and this position. So I'm going to draw the double bond, and we have two fluorines, we have two radicals. Okay, now the same thing, you're going to use these two radicals to form a new double bond between this position and this position. So you have the structure like I'm going to erase these two parts. So we have double bond here and we have a double bond here, right? So we have one fluorine in this position and other fluorine in this position. Now you have to carefully number the positions. Okay, so let's start with this. Let me take another color. Okay, I'm going to start with here and going right hand side. 1, 2, 3, 4, 5 6. Okay, 1 2 3 4 5 6. Now here I'm going to do the same thing. Start from here. I'm going to 1 2 3 4. Now here this is the fourth carbon, and this fourth carbon is connected to here. Now it's the 5, and it's connected to here, it's the 6th. Okay, be very careful about this numbering, right? So if you stretch this out, right, if you stretch this out, you can see the fluorine in this part, in this fluorine, right, this fluorine is connected to the fifth carbon, it's not the sixth carbon. So here this is the structure which we want, right? So here 1 2 3 4 5 6. So if you stretch this out, if you take this to this place and stretch this out, you will get this structure. You're going to get this structure. Here you have the fifth carbon, you have a fluorine. Fifth carbon, you have a fluorine. First carbon, you have a fluorine. The same structure. So this is the mechanism. So I hope you get the idea about it, right? So this is pretty much easy. It's a little bit fun. So what you need to do is you need to practice it yourself, right? Choose two structures. You can choose the same examples which I have taken to, and practice yourself on your own. So you will understand how to choose the bonds and how to draw the mechanism exactly. So you can watch the video if you want for the for guidance. Otherwise, do on your own. So in our next video, we will do more questions and we will start the pericyclic reactions. I hope you understood what we have talked today. If you have any questions, please feel free to comment below. I will try my best to answer those questions.